Welcome to this deep dive into Tech Unplugged. Today we're tackling a really crucial area in AI,
Mhm.
the operationalization of machine learning models, especially, the big ones, large language models.
Yeah, LLMs. It's a hot topic.
Absolutely. We got a bunch of insights here, best practices around MLOps,
Yeah.
LLMs. And our mission really is to synthesize all that, get a clear picture of the landscape, the challenges, how people are actually doing this.
Makes sense. It's moving fast.
Totally.
Right.
So we'll explore the ML model lifecycle in production, the specific stuff for LLMs, and the vital bits, security and governance.
Crucial pieces.
Think of this as like your shortcut to understanding the key themes. Okay, let's unpack this. MLOps, we hear it all the time. What's the core idea?
Yeah, so MLOps, fundamentally, it's about bringing together these different worlds, right? Data ops, DevOps, and model ops.
Okay.
It's all focused on building and maintaining ML workflows that are, well, robust and efficient. Think of it like the kitchen and the recipe needing to work together perfectly.
To consistently make good AI dishes.
Exactly, because, training a model, that's just one step. The real value comes later.
So it's not just a data scientist working alone.
No, not at all. The real magic happens when those models get out of the lab and into the real world, delivering value.
Right.
And MLOps is critical for that. It integrates the data flow, the monitoring, the feature tables, all on a unified platform with your other business data.
Building AI on solid ground, basically.
Precisely. The same ground your core operations live on.
Okay, that helps. So if an organization wants to get serious about operationalizing AI, what are the fundamental pieces they need?
You can kind of boil it down to three key things. The data itself, obviously,
Mhm.
then the code that handles the data and defines the model, and of course the trained models.
Data, code, models. Got it.
And each of these has its own journey, right?
Mhm.
Development, then staging for testing, and finally production.
And MLOps manages that whole life cycle.
That's the goal, yeah. Provides the framework.
Now, something I saw mentioned was this idea of a lakehouse in Unity Catalog. Sounds important.
Ah, yes. So the lakehouse is sort of the modern foundation, one place for all your data and AI,
Okay.
and Unity Catalog. Think of it like the super organized librarian for that lakehouse.
A librarian for data and AI. I like that.
Exactly. It's a central governance system, controls access, tracks lineage where everything came from, and helps people find stuff across different teams.
Right. Discovery.
Yeah, within, say, a Databricks environment.
So it extends that governance to the models, too, through MLflow.
Precisely. That's a key insight. You manage the entire ML lifecycle within this central system, makes sharing models way easier.
And you can trace it all back, the lineage.
Yes. Crucially, back to the exact data and code that created the model.
Why is that lineage tracking so vital? Seems like a recurring theme.
Well, for a few reasons. If a production model goes weird,
Hmm.
lineage lets you quickly figure out why. Was it the data? New code?
Yeah.
It speeds up troubleshooting massively.
Makes sense.
Plus, for compliance and regulations, that audit trail is often non-negotiable.
Okay. And then these model aliases in Unity Catalog. Clever nicknames.
Yeah, that's a good way to put it. Instead of using, version 12 everywhere,
You just use an alias.
right, you might have an alias called currently deployed, pointing to version 12. Then, when you update to version 13,
You just update the alias.
exactly. The applications using the model don't need to change. They just keep calling the alias. It adds a nice layer of abstraction.
Smart. Keeps things stable.
Mm-hmm. And Unity Catalog uses catalogs and schemas to organize all this across your environments. Dev, staging, prod.
Like separate containers for each stage.
Pretty much. You might have a dev catalog, staging catalog, prod catalog.
And inside those, we see bronze, silver, gold schemas. What's that about?
Ah, that's a really common data refinement pattern. Think of it like mining.
Okay.
Bronze is the raw ore, your source data, untouched.
Right.
Silver is refined, cleaned, maybe filtered, standardized.
Getting usable.
And gold is the final product, enriched, aggregated data, ready for BI or ML model training. Creates a clear pipeline.
Bronze, silver, gold. Got it. Okay, foundations covered. Let's talk deployment. Real-time predictions versus, say, batch processing. How do they differ?
The key difference really boils down to immediacy.
Speed.
Yeah. Real time means predictions on demand now, which means you need low latency, high throughput, handles lots of requests fast,
Okay.
batch is different, processes big chunks on a schedule, less need for that instant response.
And before we push a real-time model live, What checks do we need?
Rigorous testing is absolutely essential. Pre-deployment testing.
More than just accuracy.
Way more. You need to test the infrastructure. Can it handle the load? Stress testing. Can it recover from errors? That kind of thing.
So it's the whole machinery, not just the model's brain.
Exactly. And once it is deployed, maintaining accuracy is ongoing. Unlike batch, which might retrain periodically.
Real-time needs more constant attention.
Often, yeah. Continuous monitoring, maybe more frequent updates based on the live data stream, which leads to different deployment strategies.
Right. You mentioned common patterns, like what?
Some popular ones are A/B testing, running multiple versions side by side on a slice of users to see which performs best live.
Okay.
Then there's shadow deployment. You run a new challenger model alongside the current champion.
But don't use its predictions.
Right. Just watch how it performs on live data, risk-free, and gradual rollouts slowly ramp up traffic to the new model. Watch closely.
Allows for quick rollback if needed.
Precisely.
And how do those aliases champion challenger help here?
Oh, they're super valuable. Your champion alias points to the live model. Deploy a new one under the challenger alias.
Then you compare them using A, B, or shadow.
Exactly. If the challenger wins, you just flip the champion alias to point to the new one. Seamless transition for the apps.
Nice. And it sounds like Databricks model serving is built to simplify this.
It definitely helps take a lot of the heavy lifting out. It packages MLflow models, deploys them as APIs, and a really useful bit, it automatically logs the inputs and outputs, the inference data, which is gold for monitoring later.
Okay, let's shift to the MLOps reference architecture. What does a typical blueprint look like when building this out?
A common pattern is this deploy code workflow, basically a direct link between your Git branches and your environments, dev, staging, prod.
One-to-one mapping. Git branch equals environment.
Yeah, often. Helps with consistency, tracking changes as they move through the pipeline.
So the data scientist is working mostly in the dev environment.
Usually, yeah. They'd have read-write access to the dev catalog, freedom to experiment, and maybe read-only access to production data, or at least a recent snapshot for realistic testing in dev.
Makes sense. And the code follows a standard Git flow. Dev branch to main, then release.
Typically, yes. Work on a dev branch, merge to main when ready, then maybe a release branch for final tests and deployment. Variations exist, of course, feature branches, tags.
But the core idea is structured, version-controlled changes.
Exactly.
So, walking through this architecture end to end, what are the key steps from dev to production inference?
Okay, broadly. Starts with development coding, initial training. Then unit tests check individual code pieces.
Right.
Then integration tests make sure they work together. Then the main model training. After that, a crucial step, model validation.
Checking performance automatically.
Yep. Against predefined benchmarks. Does it meet the quality bar? If yes, it moves to model deployment.
Where it might challenge the current champion.
Exactly. Compare challenger versus champion. If challenger is better, it gets promoted. Then comes model inference, the champion serves live predictions. And finally, continuous monitoring.
That model validation gate sounds critical. What kind of checks happen there?
Usually running the new model on a holdout dataset it hasn't seen. Checking metrics, accuracy, precision, recall, whatever's relevant. Could also include checks for things like data drift. Is the new data different from the training data? And the results get logged in the model registry.
So a validated model then moves to the deployment pipeline.
Right. The pipeline manages that challenger versus champion comparison. Could be offline on historical data or online using A/B testing, gradual rollout.
Like we discussed.
Yeah. And based on that, the champion alias gets updated or it stays put.
And model serving is what actually uses that champion model for predictions.
Exactly. It loads the model version tagged as champion and provides that scalable API endpoint. And crucially, it logs the predictions.
Creating those inference tables for monitoring.
You got it. Essential for tracking performance.
And this isn't set it and forget it, right? Monitoring is continuous.
Absolutely not. That's where Lakehouse monitoring comes in. It tracks stats on the incoming data and the model's performance using those inference tables.
Looking for anomalies.
Yep. Data drift, performance drops. It can trigger alerts. Or even kick off an automated retraining job in more advanced setups.
Okay, solid overview of general MLOps. Now let's zoom in. LLMOps. Dealing with large language models, what makes that different?
Well, LLMOps is basically applying those MLOs principles, but tailored to the unique workflows of LLM apps.
Same foundation, different specific.
Pretty much. The need for robust ops is the same, but the components and how we manage them, that can look quite different.
What are some of those key LLM-specific building blocks we see?
You hear a lot about prompt engineering, right?
What?
Crafting the right input text, then
Mhm.
leveraging your own data, often using ARD retrieval augmented generation. Vector databases are key for that.
Okay.
Plus, fine-tuning existing LLMs or even sometimes pre-training them from scratch.
Prompt engineering sounds like less traditional feature engineering, more art and science.
It definitely has a different feel, lots of iteration, depends heavily on the specific LLM. What works for one might bomb on another.
So lots of trial and error.
Often, yeah.
Yeah.
Start with a prompt, check the output, tweak the prompt. And tools like MLflow are now helping track prompts and their performance too.
Interesting. And RAG retrieval augmented generation sounds powerful for grounding LLMs. How does that work?
Yeah, it's a great technique. It basically gives the LLM relevant external info just in time.
Now,
So a user asks a question. The system first searches a vector database containing your specific documents or data.
finds relevant snippets.
Right. Based on the question. Then it feeds those snippets, along with the original question, to the LLM.
Ah, so the LLM gets context.
Exactly. So it can generate a much more accurate, up-to-date answer based on your knowledge, not just its general training. It's like a just-in-time cheat sheet.
And vector databases are good for finding those snippets quickly.
Perfectly suited. They store data as vector embeddings, numerical representations of meaning, so they can do super fast similarity searches.
Find the closest matches mathematically.
Yep. And proper vector databases handle scale, metadata filtering, data updates things simple libraries might struggle with.
Got it. Now, fine-tuning versus pre-training LLMs. When do you choose which?
Good question. Fine-tuning is taking an existing pre-trained LLM.
One that already knows a lot.
Right. And you adapt it using a smaller specific data set. Good for specializing in a domain or task without the massive cost of training from scratch.
Okay.
Pre-training is building the LLM from the ground up. You do this if you have really unique data, maybe a very specialized domain language.
Or need total control. Avoid biases from other models.
Exactly. Or for strict security reasons around training data. But it's a much bigger, more expensive undertaking.
When we package things for LLM pipelines, is it always just the model itself?
Often, no. The core logic might actually be in the prompt templates, or the agents orchestrating calls or complex chains.
Ah, so you might be versioning and deploying those artifacts.
Frequently, yes,
Wow.
rather than just the base LLM weights.
And the serving infrastructure for LLMs
Mhm.
needs more horsepower.
Often, yeah. Especially for real-time inference. These models are big, computationally heavy. You might need GPUs to get decent response times.
Makes sense. Cost is always a thing. How do we minimize LLM inference costs?
Yeah, that's key. Using smaller models is one way, maybe fine-tune smaller models or distilled models where knowledge is transferred from a big one.
Okay.
Optimizing prompts, shorter queries help. Tuning inference parameters. Techniques like quantization, reducing numerical precision.
Does that impact quality?
Can do, needs careful testing. Also, traffic splitting, maybe send less critical queries to cheaper infrastructure.
And watching the results closely.
Absolutely. And getting human feedback is crucial to make sure cost saving isn't hurting the user experience.
Right. Human feedback. How does that fit into LLMOps? Seems vital for subjective outputs.
It's totally critical. Traditional metrics often fall short for LLMs, right? There isn't always one right answer.
True.
So human feedback is invaluable for evaluation during development and ongoing monitoring and production. You need processes to collect it, analyze it, and feed it back into improving the application.
Part of the continuous improvement loop.
Exactly, a core part of LLMOps.
All right, let's pivot again. Security and governance, especially with LLMs. Feels like this is getting huge attention now.
It absolutely is. As AI gets more powerful and widespread, security and governance become non-negotiable, especially with LLMs processing and generating so much text.
We hear DevSecOps. How does that apply here?
It's about embedding security throughout the entire AI lifecycle, thinking about it from day one.
Not just bolting it on at the end.
Definitely not. From data acquisition, prepping data, training, validation, deployment, monitoring, security needs to be integrated everywhere. A shared responsibility.
Okay. I saw a mention of a Databricks AI Security Framework, or DAF. What's that?
Yeah, the DEF offers a structured way to think about AI security risks. It maps out potential threats across all components, from raw data to model serving, and suggests mitigation controls for each stage.
Let's break that down. Risks in the data stage.
Yeah.
What are we worried about there?
Several things. Lack of good access logs makes it hard to track who did what. Data pre-processing integrity. Could data be tampered with during prep? Adversarial partitions manipulating data splits to fool the model. And with foundation models, the security of their training data is a big one, plus just general weak governance over your own training data.
And how do we counter those data risks?
Strong authentication is key. SSO, MFA, network controls like IP allow listing or private links, securing model features, critically, tracking data lineage, know where it came from, how it changed, and robust catalog governance, audit trails.
What about risks in the algorithms themselves?
Well, the choice matters. Offline learning trained on static data generally has a smaller attack surface than online learning systems that constantly ingest new data.
Because online systems could be hit with poison data.
Potentially, yeah. So the algorithm choice needs to consider the security context.
And evaluation. Risks there too.
Definitely. Insufficient or biased evaluation data is a big one. The model looks good in testing.
But then goes off the rails in the real world.
Exactly. Biases, hallucinations, toxic output. Especially with LLMs, where checking all possible outputs is tough. Makes it hard to trust the model's safety.
Moving to the models themselves, what are the worries?
Model attribution, who owns this model, lack of clarity causes issues, unauthorized access to the model files,
Stealing the model.
or just accessing it improperly. Also, data leakage. Can sensitive training data be extracted from the model? And if you use third-party pre-trained models, they might have hidden backdoors.
Oof. Okay, and when the model is live, serving predictions, inference time. What threats?
Several. Model inversion, trying to reconstruct training data from outputs.
Yikes.
Mapping the model's ontology or decision boundaries. LLM hallucinations could reveal sensitive info potentially. API vulnerabilities.
Yeah.
And a big one for LLMs, prompt injection.
Tricking the model with clever inputs.
Yeah, crafting prompts to bypass safety filters or make it do unintended things.
That's a lot of potential holes. How do we
Yeah.
plug them? What defenses?
Robust access controls, obviously. Encrypting models at rest and in transit. Securing the serving endpoints. Rate limiting to stop abuse. For LLMs specifically, RG helps ground responses. Fine-tuning on safe data. Pre-training with safety in mind. And deploying AI guardrails.
The guardrails, like content filters.
Exactly. Filtering unsafe content. Detecting PII. Maybe keyword blocking. Another layer of defense.
Can Lakehouse monitoring help with security too? We talked about performance monitoring.
Yes, absolutely. By tracking data stats and model output patterns, it can spot anomalies that might signal a security issue.
Like sudden weird predictions.
Could be, yeah. An unexpected shift might indicate a compromise or attack.
And MLflow's tracking helps governance from a security angle too.
Definitely. That detailed audit trail of experiments, models, versions, it's crucial for reproducibility, accountability, which are core to good governance and security. Tags, aliases help organize too.
What about newer tools like Mosaic AI Vector Search and AI Gateway? How do they fit into Gen AI security?
Good point. Vector search has built-in security, isolation, auth, encryption, and integrating with Unity Catalog means governance policies extend to your vectors.
Okay.
And AI Gateway is like a central control tower for LLM endpoints. It offers those AI guardrails we mentioned, rate limiting, centralized monitoring, key for managing access and security.
We also hear about AI red teaming. What's that about?
It's basically ethical hacking for AI. Simulating attacks automated and manual to proactively find vulnerabilities. For LLMs, that means trying adversarial prompts, trying to break safety filters. For traditional models, maybe creating inputs to fool them.
Finding weaknesses before bad actors do.
Exactly. A critical proactive step.
And it's not just the model, right? There's supply chain security for AI.
Correct. Thinking about the whole ecosystem, where did the data come from? How secure is the training platform? Are third-party libraries safe?
The whole pipeline.
Yeah. Mitigating risks all along the chain?
And if something does go wrong,
Yeah.
an AI security incident,
You need an AI incident response plan, an AI IRP. Specific procedures for AML incidents, which can differ from standard IT security incidents. How to handle data poisoning, model theft, sensitive LLM outputs.
got it. It really feels like responsible AI ties all this together: security, governance, ethics.
Absolutely. Responsible AI is about deploying AI ethically, legally, safely. It means fairness, bias mitigation, transparency, explainability.
And security and compliance are fundamental pillars.
Exactly. Data protection, model protection. And MLOps is how you operationalize these responsible AI principles across the lifecycle.
So getting LLMOps right brings benefits beyond just checking boxes.
Oh, for sure. Better performance, reliability, scalability, efficiency. It enables that responsible AI governance and even helps with FinOps managing the costs of these powerful models.
Wow, we've covered a huge amount of ground here, really journeyed through MLOps MLOps and LLMOps, it's clear operationalizing AI, especially with LLMs, is complex but absolutely vital.
Yeah, it really is. From MLOps foundations and the Lakehouse with Unity Catalog to specific LLMops challenges like RAG and fine-tuning. And underpinning it all, security and responsible AI. It's a demanding field.
Definitely. And the focus on monitoring, proactive security, ethics, it shows how the field is maturing, how much responsibility is needed as AI becomes more embedded everywhere.
Mm-hmm. Hopefully this deep dive gives folks a solid foundation on the key concepts and trends. What questions does this spark now? What areas are people curious to explore further?
Great questions to ponder. Thanks for diving deep with us into Tech Unplugged. Stay curious.